This is a session to go over the early years, many of which seem to have been forgotten, and some of the early people, many of whom seem to have been reduced to distant memories. I just thought I'd begin by showing you what the graduate catalog looked like the year I came in. You'll notice that there were maybe a dozen courses, most of which were mathematics and numerical analysis, and those of us who wanted to come and study computer science would try to flock to the ones that didn't have numerical analysis in them, but it was an interesting challenge. In the early days of the department was in engineering administration, and a very small area of the building allocated to the department. We certainly didn't fit. We needed more space. All these students were coming. So a very important date was '67 when the department moved to the Math Sciences building. We had the 4th and some of the 7th floor, plus the computer in the basement. It was a great place for many years. A lot of things happened, as you'll see later today. But we didn't fit. We needed more space. From day one, we didn't fit, as you will see. So in 1985, they moved to the old gymnasium. We didn't fit there either. So recently, they moved here to Lawson, and we still don't fit. So I am just extrapolating from this. One of the things I learned in my numerical analysis course, the one that I actually had to take, was the concept of extrapolation. So I've extrapolated to the future. So I see the Purdue College and then the Computer Science University of Purdue. Maybe then we'll have enough room for the department. Okay, enough of that. Now let's move to the next group of slides, which will be done by Mr. Hal Hart, the birth of the CS discipline. How did things get started? And Hal, you have the microphone.
50 years ago, in the spring of 1963, I had not heard of computer sciences, and I didn't hear about it for a few years after that. I was a senior in Valparaiso High School up the road, so I've got a 50th high school reunion coming up this year. Little did I know, but I found out months later, there was a fake religion being created at Carleton to circumvent the college's religion requirement. And it succeeded. The religion requirement was gone within a year. The Reformed Druids of North America lived on, and they became part of the Purdue story that you'll hear more about later. So they have a reunion coming up next month, 50th reunion. So here we are at this 50th reunion, and I realized we were all of the second 5 years. I didn't know much about the origin of the department. And I got curious. Next, please. I asked myself 5 questions. Was there any presence of computer science in academia? I probably had heard of computer programming in '63. I'd heard of computers. My dad was a chemical engineer at Standard Oil of Indiana. He had been managing a refinery computer automation project in the late 50s. And he told me he kind of thought these computers were a fad and they weren't going to work out. But he was wrong. Things were going on. So I've got one chart talking about what I think I found out pre-computer science departments in academia. And then what triggered the formation of this department, which most people accept was the first computer sciences department in the nation. And I was curious, where'd the faculty come from, since nobody had degrees in this field? What were the qualifications? What were they looking for? And then I asked myself, in our era, a whole bunch of new faculty came in, and only one that I'm aware of, there were probably 2 or 3, had CS degrees. Why did all the rest of those people decide to apply outside their field and come to this unproven new venture? Next chart, please. The story in academia started back. Well, then I made a mistake, and we're being recorded, and
Ruth has had 40 years to perfect her correction of how.
Okay, we don't have my current charts up there, Denny. I don't know what you did. We loaded it
You want this way?
15 minutes ago. That's okay. Just we'll talk from this. I had some pictures and all that are missing. The point of this chart is to show you that it was an academic research question starting 30 years earlier. The theory of computability. What is computation? What are the limits of automated computation? What are the things that, if we automate their computations, would not be solvable, or whose solutions, algorithms would not end? This laid the groundwork for a lot of electronics and hardware development, with programming software coming later. So that's where it starts in academia, as far as I can tell. Next, please. At Purdue, it started actually 15 years before the department was formed. Now, many of us remember from our era, L. Dwayne Pyle. He was the assistant chairman of the department then. And unfortunately, he died too young, about 2 decades ago. But we're very lucky to have his daughter, Robin, here today. We actually have 2 daughters, but Robin is going to now pick up the story. It turned out that John Rice and Saul Rosen, 20-some years ago, give or take, decided it was important to document the origin of the department. And they were writing things up, and they discovered Dwayne Pyle had done this in his own style earlier, and they used his materials as a great source. So the 3 of them are really the chroniclers of the department. But John and Saul both admitted that, oh my gosh, we didn't know that Dwayne Pyle had been writing this up 20 years earlier. So Robin is almost wired up, and I give you Robin Pyle.
Hello, everybody. I've been given 7 minutes, so I'm going to talk as fast as my father used to do. I've heard from a number of his students, writing with one hand and erasing with the other, okay? And I'm going to quote some people, my father's document, which recollections regarding the history of computing at Purdue, which he wrote in June of '82, and also by permission, I hope, of Dr. Rice. I'm going to quote some from his document, The Origins of Computing and Computer Science at Purdue University. Is that okay? Okay, all right. So I'm hopefully going to get some of these dates and names right. My main purpose is to give you a sense of what it was like and what I remember, actually, because I was born in '57. So I'm going to talk about the feeling of what was happening and try to mention things. But for the definitive dates and names, you must look at these 2 documents. But anyhow, my father really was convinced that Dr. Carl Cossack, who apparently joined the math department in 1947, was the early person that got Purdue headed in the directions of computing. And so he came to the math department, but he apparently was a statistician, so he set up the statistical lab and started working. And the first machine they had was an IBM card programmed calculator. So when my father showed up as a student in 1952, that same time, he was learning to program this calculator. Another very important person brought in by Dr. Cossack, Alan Perlis, who was a fresh PhD out at MIT and was apparently hopefully is quite brilliant. I'm not sure if he's still living. He came in, and between he and Dr. Cossack, they were moving ahead. So now the stat lab became the stat and computational lab. So that was essentially the first days of what was going to become the Computer Science Center. So here's my father, as he put it, a lowly graduate student, taking courses from Alan Perlis and learning all these things, and Dick Kenyon also, who actually may be viewing this in California as we speak. He couldn't be here because he's playing for a symphony in a couple days, and they are in rehearsal. He's an amateur violinist. And now Dick and my father together essentially were a dynamic duo with other people working in the early days. My father actually remembers in his document helping unload the Datatron off the truck. So that's a pretty good thing to remember. But what was happening at the time was really important to look at the history, because there was all this shifting interest. Who was responsible? Did it stay completely under math? There were a lot of people in engineering who wanted to use computers. So all sorts of things started happening. And in the middle of this, I think it seems like Alan Perlis and Dr. Cossack, they were continuing to move ahead. But what happened was Dr. Perlis left. He went to Carnegie Mellon. He was given a choice position, left. And suddenly, my father was, okay, all right. And he still didn't have his PhD. That's why he became the acting head of this program. And it was then called the Computational Division. It was essentially a baby computer science department. I remember my father staying late at work, staying overnight quite often. He spent many nights there. I think they had cots. They slept they slept there with that Datatron. So and Richard, I believe, helped write the compiler. So all of this was happening without anyone directly saying, this is where we should go. But Dr. Cossack was a far-thinking man, I can tell from reading about him. And he was pushing the president of the university. He had issues with the dean that was over him, whose name was Dean Ayers. And at one point, a critical point apparently, he asked the president, President Hovde, please move the mathematical department out of the School of Science, Education, and Humanities. And there was that kind of problem, and it didn't happen. So in 1959, after he had asked this and it didn't happen, he left. Now when Dr. Cossack left, and Al Perlis had already left, who do you have standing there holding the reins? No one. So the reins fell to my father and essentially Dick Kenyon, and they together were running this computer center. And they did all sorts of, there's wonderful stories which you can read in my father's document about how people were fighting for time on this computer. And one man who went in there and he had a program he needed to put on the computer to fix something, and he literally locked the doors for 36 hours and wouldn't answer the phone. And people were beating on the door. That's how much the competition was to work on this machine. And of course, different engineering programs, different projects, they wanted it. I want it for this, I want it for that. So there was all this interest, but there was not a structure. And so fortunately for my father and everybody else, Dean Hovde said, this is a problem. And he was open, he was aware, he was interested. And so after Dr. Cossack left, he had his assistant, Dr. Hicks, set up an ad hoc committee, which apparently is the source of all these memos and documents that describe how this committee essentially set up the structure for what would become the computer science department. And they had initially just started with people that were already recognized heads of departments and vice presidents, but apparently right after the first meeting, when Virgil Anderson at that point was heading the stat lab, and my father was his, as my father put it, I was his chief cook and bottle washer, because Virgil didn't want to run the computer side, and he went, here, Dwayne, you've been doing it, go for it. So my father was running this, and at this meeting with all these guys who, were important, they were, okay, we need somebody who actually knows what's happening in the computer center. So they said, okay, Dwayne Powell, come on. So my father found himself suddenly as a fresh PhD. Actually, he was just finishing his PhD in 1960. He was suddenly on this committee that was very wide-ranging and all sorts of people involved, very exciting time. My father, in the 70s or 80s at some point, talked to his kids about how we should read this book, The Right Stuff. And you guys are probably aware of that book about the early astronauts. That's what my father said, that's what it was like. It was like we were running headlong in this direction, and we didn't know the risks we were taking. We knew there were risks. We didn't know where we were going. We just knew we had to go that way. And so they were young, so they could do it. And they were rushing, and they were doing what they could. And it was so fascinating because actually everything they put in this ad hoc committee recommendations eventually came to pass. And it was ultimately a structure of a computer science department and a computer center with graduate training. It didn't include the undergraduate training yet. So then what happened? Things got worse with the departmental situation, and the president at that time, President Hovde, moved the math department, math and statistics out of where it had been, and said, okay, we're going to put it under engineering. So then, suddenly, that was good in many ways, but bad, not bad, but a little scary, because suddenly everybody who was engineering went, great, because there was competition to use the machine. And there was so much need for the machine that my father actually set up this bizarre program. I remember this, you may remember too, where they sent guys taking tapes who would drive to Chicago and Indianapolis. Yes? Oh, thank you. To run these tapes. But ultimately, Dean Hawkins said to my father, who my father really respected, said, you know, here's this man who has this huge reputation, said to him, I'm going to bring in people, you know, deans and vice presidents, and I want you to teach us all, and give us lectures about where we should go with computing, which my father did. And his comment in here is that Dean Hawkins was an apt pupil. But anyhow, all that happened. Dean Hawkins was able to prevail enough. They got more equipment. And just in time, 1961, the interest took over. And the one thing I did want to read from my father's writings that he felt very strongly about, which we were just referring to here, how there are people who need to be credited. Here's a list of the people that he felt needed to be credited. He said, in achieving the explosive growth that took place, he's referring now to Felix Haas. Felix was building on a foundation which had been established by the hard work and frequent frustrations experienced by many others who had paved the way before him. It was a situation where Felix and Sam Conti were brought in as outside experts. They told the administration much the same that Cossack and Perlis and Brock, Virgil Anderson, Dick Kenyon, and myself and the others had been telling them. However, fortunately, at this point in 61, 62, things were shifting in the nation, and suddenly the Purdue administration said, okay, let's go this way. But all that work, all these people who have often, our names are not been heard, I think it's really important at this time, this 50th year, to honor these people and to record what they did. Thank you very much.
At this point, I'll pick up and finish the story. Yes, Dr. Rice. Yes, please comment. There you have it from probably an undisputable source now, 50-some years later. Well, the culmination of this germination process, which you see took many years, was the decision to hire a person of national stature in computing. And the person hired was Sam Conti from an aerospace company in California called Space Technology Laboratories, became TRW soon after that. I'll mention that again in a minute or two. The thing that Sam did, surely with the help of the others who were there, was he had the political savvy and the connections to bring in the big bucks. The NSF money and other funding sources that the government had available for other sciences, he persuaded them that this was the next frontier science. Next, please. Sam was hired and chartered to build a department. He had 2 faculty members there at the time. He used Dwayne Pyle and Richard Kenyon. He hired Saul Rosen, a senior person he'd known earlier, and Robert Korfbach, a new PhD from Michigan. Next, please. Those were the original 5 faculty. They were able to deliver approximately 20 courses a year. That was enough to launch a master's program. And their first master's came out 2 years later. Here is a listing of other faculty that were hired during the first 10 years of the department, stopping short of 1970. Actually, the remainder hired in the 60s are listed here. Some of these dates I actually saw on the floor out there are off by a year maybe, but this is close enough. This represents the faculty that those of us in the second 5 years knew. And there was a distinct difference between the older faculty. They were professor. We approached them with reverence. The younger faculty acted like us, and they penetrated our social circles. And this became a wonderful time for years because the boundary between faculty and graduate students was narrowed, if not eliminated. Murray Halstead is the one who's worth mentioning. He was the other heavyweight besides Saul Rosen, who was in programming languages or programming systems, as they were called at that time. How many of you here wrote a pilot compiler, a self-compiler? You described the extensions of the language in the Bootstrap language. You compiled it through the Bootstrap compiler, and you had a new, more powerful compiler. Because you took advantage of the optimizations possible from those new features, the compilers got smaller and smaller as the language got bigger. A wonderful, wow, this just blew my mind. And all of a sudden, I knew I was in on something special. Moving on. Here are a set of milestones of the department taken from a document by Drs. Rice and Rosen. You can see there the dates. Before I arrived, 100 masters had been awarded. That's impressive, I think, in the first 5 years of the department. And shortly after I earned mine with Ruth, I don't know if I was the quickest to ever get a master's. I was fighting the draft, and I got it in two semesters. I entered in fall of 68 and graduated in spring of 69. But the 200th masters came soon after that. The faculty size was exploding. If you read Dr. Rice's documentation, crises actually started to bubble forth due to the explosion in both faculty and student demand. We weren't aware of that. It happened around 1980, I believe, when the crises happened. That was after our time. It's not part of the formation story. It's a typical thing as an enterprise is birthed and it grows, and all of a sudden there's a different set of phenomena that happen to it. We were before that. Last chart, please. Yeah, again, this is my previous version of them. I don't know why the young faculty came. I asked a few of them that we were in touch with, and the most concrete answer I got was from Herb Schwetman, who said, I had a PhD in computer science, Hal, from the University of Texas. I was trying to answer the question, why did people convert themselves from double E or math or whatever, and I'm just speculating here. They recognized the same thing we did. There were more jobs in computer science departments. By 1968, 69, 70, there were probably more than a dozen computer science departments, and they were all trying to grow rapidly. By the mid-70s, there were dozens, if not 100. Every large university had them by then. So it was just inevitable. It was a necessity that in addition to the new PhDs coming out, which was an average lag of 5 to 8 years from entry to graduate school, that they had to supplement that with other qualified people who had undoubtedly used computers and done programming. So that's the end of my 5 questions. That's what I learned. I hope that this is consistent with your memories, that I may have illuminated a thing or two you didn't know. I certainly didn't know about what Purdue did in the 50s computing-wise, nor even exactly the founding of the department and who the first faculty were. Questions? Thank you.
Ruth is next, right?
Yes. It's good to be first. And because Purdue was first, that enabled them to build a lead that it took a long time to overcome. Thank you.
Hi, I'm the other half of the heart team, for those of you who don't know me. And I thought I was given 5 minutes to talk about women in computer science, which I guess says something in itself. But I just have a couple of slides. Go ahead. So as you all know, I'm sure women have been in the computer field as long as there have been computers. And you start off with Ada, Countess of Lovelace, who Hal has great love for, and who was Charles Babbage's programmer. The ENIAC programmers in World War II were all women. Hal points out that it was considered a secretarial job back then, computer programming. And then famous people named, such as Grace Hopper and Jean Sammet and Fran Allen and the list goes on. So there were always women there. So if we were looking for role models, which I don't know that we were, there were plenty of them there. I was a math major, as most of the people in this room were, and somewhere around my junior year, I took a computer science class, but beyond that, I got into complex analysis and things like that and said, what's the point? And what can you do with a math degree other than teach, which I didn't want to do, although I ended up doing it. And so I thought computer science was a good thing, and that's why I ended up here. So go ahead. So when we were, yes, John. Uh-huh. Rockwell. Right, Rockwell now. That's what they believed. Well, right. And, interestingly, it was common, not necessarily high school, but through my working career, I met lots of women who had started out as art history majors or English majors or whatever, and made their way to companies that trained them to do programming, and as long as they had a logical mind and could figure out what to do, they were very successful. So things changed. Anyway, I entered in the fall of 1967, and I believe, although I can't remember them all, that there were 5 of us then. I was there, Mary Dickey Cooper was there, and I remember one other. And Mary's pointed out somebody showed up in January as well, but no, Mary Pickett was in, who did you say it was? Yeah. Yeah, Mary Ellen Lamphere.
Judy Bicknell.
What?
Judy Bicknell. Judy Fuller. Judy Fuller was 68.
68, yeah. Anyway, in the fall of 67, there weren't a lot of us, but in the fall of 68, and I don't know whether it had anything to do with the fact that there were no longer any grad school deferments for graduating seniors or what, but all of a sudden a flood of women came in. And at that point, my gut feel is it was about 40% women at that, through the years that we were there. There were a lot of women. We generally had less computing experience as undergraduates. If you talk to Gary or Rich or even Hal, they did things. They worked for computer centers. They did that. I was a math major. I came in as a math major, and that was my history, and I think that was true of most of us. And there was no overt discrimination, although, I put this on the slide, and then Catherine Vonnegut, who was a few years behind me, said the same thing to me today without prompting. No one ever expected women to go beyond their master's degree. A master's degree was there, and there were no PhDs. And I believe that Dorothy Denning was the first woman PhD here. She got her degree in 1975. So you can see the first one was 66. I think the first male PhD was 66. So there was that. But it was good. And go on, have the next slide. I think I have another one. But something that I'm sure all of the current professors know, and I think most of the rest of us, is that something happened in computer science somewhere around 1980, and all of a sudden the percentage of women went down. The top line on this chart, this is from a New York Times article, I think from a few years ago, is the percentage of men, and it went down in the 80s and 90s as people figured out that getting MBAs was much more lucrative. But it never went down as far as the number of women went down, and then it went up again, and the number of women never went up. And I know we did an industry and academia has done the same thing, trying to figure out why this is. And as far as I know, there are a lot of theories, which I think I have on the next chart. Here's the numbers again. In 1985, 37% of bachelor's degrees in computer science went to women. In 2010, it was 18%. We had a daughter who got her CS degree from Brown in 2001, and we were shocked at the few number of women who were there in the class. I think there were about 5 out of 75. And yeah, some of the explanations, video games is a popular one. Video games, are directed toward boys, and girls start feeling that that's not a good thing to do. I kind of have a feeling that part of the issue is that other fields opened up to women. And so they had more opportunities. Back in the 60s, this was a really, really good job, and there wasn't any real discrimination. And so a lot of women chose to go into it. Now they become doctors or lawyers or MBAs or other things that they could do. So, but I don't know if any of the current professors have any more, ideas about that, but that's what I have to say.
I have an idea, as an observation. I got to the point of being a principal fellow by the time I had retired from Reagan. My last 5 bosses, 3 of the 5 were women, all of whom had majored in computer science in the 70s. So they got very high up in the company, and the problem was there was no successors. There were no women to follow them because of the dip that you already mentioned.
We had the same experience at TRW. There were many, women managers and everything, but the last several years when we were hiring, there just weren't that many out there. Yeah, that's another thing. I don't think anybody really knows. There's a lot of speculation, and it's somewhat a waste.
But it's also all those other fields that opened up that we mentioned. CS may have broken the barrier first, early.
Thank you, Ruth. Okay, as you may have noticed from the program, we've tried to mix styles. Every session is rather different in character. So if you really like one of the sessions, we probably won't have another one just like it. On the other hand, if you say, I'd like a different kind of session, maybe there's one coming up. The next one we're going to talk about has to do with the Math Sciences building. And let's see here. No, this is the wrong slide. There we go. It's this one. We call it Adventures in the Math Sciences building because that's, in fact, what we did. We had lots of adventures. John Berenberg is going to run this panel, but I'm going to make a couple of introductory remarks. One of them is that the Math Sciences building was a really, from my point of view, very crucial milestone in the history of the department. And the reason is it was the first time we actually had the whole floor of a building to ourselves. And not only that, we basically did a lot of things in defining the way the building should be done that made computer science more effective. For example, the way we had the computer center laid out. And so it was really a very important milestone in the history. And what you're about to see are some of the adventures we had in that building. Oh, we will. Great, thank you. And John Berenberg is going to take over from now, but he's going to enlist the assistance of a number of other people from the audience. So, John.
Okay. I enrolled in the graduate program here in the fall of 1966, and I came, I got my bachelor in mathematics, but my freshman year as an undergraduate, I got a job in the computer center of my college, Cornell University. And the very first program I ever wrote, just to prove that I could write a program, I tried to write a simple loop to generate prime numbers, and that program discovered a bug in the compiler, as a result of which I was invited to join the undergraduate staff of the computer center. So I have nothing against mathematics. Mathematics served me very well, but by the time I graduated, I knew that programming was what I really wanted to do. And that's why I applied to Purdue, and I entered with a graduate research assistantship. And having a graduate research assistantship meant that, hello, I thought I turned, yeah, there it is. Meant that I was given a desk in the engineering administration building. And Dr. Pyle was in charge of placing us at desks in this building, and he was trying to crowd what we felt were too many people into the same room. And so it is at this time in the history of the department that we invented Dave Zichterman. We kept telling Dr. Pyle that no, that desk was already in use by Dave Zichterman, and he said, "Where is he? I never see him." "Oh, he was just here. You just missed him," or his grandmother died, or whatever. You know. Now, during the course of preparing all our notes, a lot of us communicated by email. And there are some people who feel that Dave's last name was Zimmerman and have photographic proof. There was a mailbox after we had moved to the math sciences building that was labeled Dave Zimmerman. But I'm here to tell you his original name was Zichterman. Okay, so I was very happy with the move to be a computer scientist, and I went on to have a career in research and development departments, first for IBM Corporation and lastly with Siemens Corporation. Denny, I want to show the slide about the patent. It's at the bottom, I think. Yeah. My name is, come on. My name is on a couple of U.S. patents, and my advice to you, if you plan to be part of a team that's getting patents, is to have the first alphabetical last name. Mr. Taylor was my boss, but he's last there, and in the summaries on the U.S. Patent Office site, it says Berenberg et al. So. That's my lesson for you. I have no idea what this patent is about. When the patent department gets a hold of whatever it is you did, they turn it into language that you absolutely cannot understand and seems to have no... I think this is a patent for multiplication, but I'm not exactly sure. Okay, now let's go back to the slides. So when oh, come on, there. And we want to make it bigger. Yes. Somehow it went back to the beginning. So when I entered and my cohort entered, the graduate students who enrolled then were going to be the last ones to start at INAD. And that month that we started also saw the appointment of John Steele as Associate Director of the Computer Center, and he was responsible for its entire operation. At that time in engineering administration, we had an IBM 74 and an IBM System 360 Model 40. The reason we had an IBM System 360 at all was that Purdue's plan was to get from IBM their not yet ready Model 67, their time-sharing computer. And this would satisfy the batch and time-sharing requirements of a growing university. Also, that same month, the Computer Science Center announced for the first time that it would now operate 24/7. And just for historical reference, the compilers that we had available to us were for Fortran and Algol and COBOL and Snowball and MAD and Lisp and SLIP and a compiler called TMG, which stands for Transmogrify, a wonderful word. And there was at least one course that required us to be able to program all of these languages. Also, at that time, the Purdue University Fast Fortran translator, running under the Purdue time-sharing system, PTSS, could compile as many as 50 Fortran 4 statements per second, although the programs could occupy at most 15,000 words of memory. Just a little historical perspective. Then in March, we announced that we would support a new language, PL1, and I put this in quotes because I actually found it. It combines some of the best features of COBOL and Fortran. Also, the installation of the Control Data 6500 computer was scheduled for August, which would be after the planned move to the new building. That later did slip to October. But what happened to the 360? I'll get to it. So in August of '67, the department and the computer center moved to the new math sciences building. And as Dennis already remarked, the faculty and the grad students had offices and desks on one floor. There was much late night socializing and food and drink expeditions. I'm not kidding about the socializing. Gary, where was Oktoberfest held?
If I remember.
Okay.
And that wasn't the only one, because we have flyers.
Right, it says again this year. So. The building features. We did not really like the furniture. So the furniture was tiny and it seemed flimsy. At that time, there was only one Xerox copy machine for the entire building. It was up on the math administration floor. It wasn't self-service. It was behind a counter, and you couldn't get copies made unless you had a charge code, which most people did not have. Instead, we used a spirit duplicator with smelly blue or purple, and the other consequence of people needing to use that, I looked at my class handouts, and all of them are handwritten by the professors for the spirit duplicator. That was the technology that we had. One very famous thing that we didn't like about the building was the elevators. We don't know if they ever managed to program the elevators properly. My particular complaint, since I needed to get down to the ground floor below the main entry floor, was that during rush hours, you would press the down arrow to summon the elevator. It would arrive full of people. It would take them 10 or 15 or 20 seconds to exit, during which time the elevator would time out, the down light would go off, the up light would go on. Even if you got onto the elevator and rode all the way to the top and took it down again, the people getting out. So during class times, you couldn't. Okay.
That was probably advertised as an optimization. Try to reverse engineer the algorithm, but
Okay. Now I'm going to back this up all the way to the picture of the building. This end of the building is where the auditorium is. Okay, fine, and the computer center offices were on the floor underneath it. But what some of you may not realize is that at this end of the building, also sticking out from the building, just like the auditorium, underground there's a crypt or catacomb. You see, the control data computer, even if you disassembled all its pieces, many of the pieces were too big to fit in the elevator. And so what's at this end of the building is concrete slabs that could be lifted up by a giant crane, and the computer, when it was installed in 1967, was lowered down into them and then could be dragged onto the computer floor. You can't see the slabs today. We visited the building, and they've put some kind of electrical power thing on top of it, but we know it's there. All right, so now find. Okay, I don't want you to concentrate too much on these pictures, but our 7094 had 32K of memory. And the dual processor 6500, which, big as the whole length of the building, it had 64K of memory. I don't know how.
I want to make an observation at this point that the big disk from CDC that wouldn't fit in the elevator, I looked at the capacity of that. The amount of material we received in order to produce this presentation exceeds the capacity.
Okay. In September of 1968, the Computer Science Department and the Computer Center were finally formally split. They'd previously all been under Dr. Conti, and now Professor Saul Rosen became the full-time director of the center, and Professor Samuel Conti remained the head of the department. And I found some cover sheets of the two. This, again, I don't need you to concentrate on the contents that much, although when you later look at our website, you can see this is the staff of the computer center at that time. Dr. Rosen, John Steele. Louise Faust was my landlady. She's the secretary of the center, and she and her husband were refurbishing the basement of their apartment, of their home just a couple of blocks off campus, and Dennis and I and one other moved into it. And that was keeping it all in the family. Also, just to get the timing in your minds, in September of 1968, IFIP first published its draft report on the algorithmic language Algol 68, and Peter Nauer, who wrote the Algol 60 report, and our own Saul Rosen, both declared that the report was almost unreadable. Then in December of 1969, moving into the 19th century, 20th century, the center acquired a second 7094. It was used, of course. Its original list price had been $2 million, and according to documents I found, we paid $24,000 for it. It was called the Oil 94 because of how it was cooled. Our original one had been air-cooled. Yes, the memory was, yeah. And Dr. Rice asked me to remind you that the NAPS project still needs a substantial number of functions. And I don't know whether, he says the graduate committee has adopted a new requirement. I don't know whether that was a joke or not. You don't even remember it. Right, okay. All right. So that was all I had to say about the move, but we got a lot of other submissions about the computer center itself, so that became a separate topic. And so here we have on the left the dual screen console of the 6500 and its probably 600 card per minute punch card reader. We had 2 card readers? Okay, and here's, again, don't try to read all the text, but why there was a CDC 6500 instead of that originally planned IBM 360 Model 67 time-sharing version. Very simply, IBM dropped the ball. And we've got some more on our website, but I found a paper copy that I couldn't scan of Dr. Conti's 1967 3-year budget proposal to NSF, in which he went into some very nice detail about what happened. IBM thought that they could deliver the hardware of the 67 to us within a year, but that it might be just experimental. I'll tell you frankly, after I left Purdue and went to work for IBM, I participated in IBM's alpha test of CP67 CMS, Control Program 67, the Cambridge Monitor System. And so this was years after I left Purdue, and it was still not quite ready. So our decision, it's not funny. Our decision, Purdue's decision to go with a different system was well done. And formal proposals were received from IBM, who wanted us to go with a 67 attached to a Model 75, but it wouldn't be time sharing, and that would cost about $4 million. UNIVAC proposed a dual processor 1108 for about the same price, and CDC proposed its dual processor 6500 for just $3 million. And Burroughs proposed a system which would not be available. It hadn't even been built yet, and so that was out of the running from the beginning. And so basically, Conti says that we thought that the 3 computers in the running were about equal in capability, and the $1 million in price was the deciding factor. Okay, that's how the decision was made. I showed you before that we bought a second 7094, and there's a whole page of comments from Saul Rosen in our technical newsletter, this one from December '69, explaining our reasoning to do it, and it was just to improve the batch turnaround using the existing puffed system, the fast Fortran translator. Now, the graduate students all helped, during our era, all helped to enhance the computer center's offerings. We participated in the development of MACE, the operating system. Individuals of us ported many of the existing 7094 programs to new platforms. So here's Dennis Fraley porting SLIP to the 360. And then, see, this last item says that there was a program called Text90 that got turned into TextJab. Some of you know that my initials are JAB, and so, you know. See, the history of that one was this. Originally, there was Text90, which was a share users group program that Purdue made available to us on its 7094. And This was a document preparation program. You prepared punched cards containing the words of your document with little marks to indicate uppercase or underline or paragraph. But I want to give credit where credit is due. That program was not originated by JAB. It was originally written, sorry. Don't do that. It was originally written at IBM. So that's the front page from that manual. But what happened here was that in the spring of 1968, we had the CS 698 project seminar. And these people, some of these people are here today, but I recognize almost all of their names. We were all working on improvements to the offerings of the computer center. And John Berenberg and Toby Burke, who's not here, had a project called Text Handling Systems. This is not for the computer center. This is a department seminar. And I don't know why, I was hoping Toby was going to be here. I have no recollection of why he deferred to me on the naming rights.
It's unpronounced.
But right there at the bottom, it says it's by me and by Toby in the spring.
B-E-R-E is earlier in the alphabet. B-E-R-E.
Oh, yeah, oh, okay.
It's good to be first.
Yeah. We were not humble. I didn't remember this, but in our department report for that seminar, we claimed the following. A tech report from the University of Maryland for the Office of Naval Research said, quote, Text 90 is the more sophisticated of a variety of text editing programs available. So Toby and I then proposed that on the 6500, even a small addition to Text 90 would give us the most sophisticated text editing program available. The manual itself didn't say who wrote it. There are no, that was true of most of the documents in the computer center at the time. And I'm proposing maybe you were supposed to think that JAB was an action verb. I learned during our correspondence leading up to this conference that the program had a life after we did it. In 1971, graduate student Michael D. Shapiro released TextJab C to produce TextJab output not just on a typewriter or a printer, but on an electrostatic printer. And then Rich Reagan gave me this quote. At least at CDC where I took it, it had a long and productive lifetime, morphing to several programs. I think I got them all. Several thousand design documents offered. I'm flattered, gratified. And the open source and collaborative nature are really what characterize not just TextJab, but most of the things that we did during that era. I'm very proud to have participated in it and gratified that many of these programs had such a life. Now this is another topic. In our fourth floor warren of offices, there was a room that had the public teletype, and its blackboard periodically had competitions with no prize. It was just something to do. We were always collaboratively developing programming tricks. And one of them was a no-loop way to delete trailing blanks. That's pretty clever. It involves exclusive ORs and subtracts. And this guy got an article out of it. A note on deleting trailing, jeez. Okay, now I'm going to need some help. I've already told you about Zichterman and Zimmerman, so forget that. But apparently at some point that completely escaped my memory, there was something about a door decorating contest. And these are the only pictures that we got, and I understood there were others. Does anybody?
Yes, those are students. Yes, and she claims that she won. No evidence about that.
I will grant her winning. You're loud.
The one I remember,
It's for the recording.
Oh, okay. I was in 407, and my office mate, who was Joan Stupensky, and maybe somebody else, we refused to participate. But Hal and Tom Lang and Tom Clavin and Bob Winter, I believe, did one for their door, which was after about the moon landing, which might have been a later year. I don't know. 68. And anyway, they took a picture of the moon and pasted card Chad lovingly yes, card Chad. Oh, colored card Chad. Maybe you should be talking here, but I was sure that one was going to win. So we think Sue might have fixed it. So the reason for the door decorating contest was that the facilities manager, who was up on the 9th floor, deemed that nothing was going to be allowed on the doors. You know, people had bulletin boards or whatever, and she said nothing was, and we rebelled. So that was the door decorating.
And Denny has something to say.
Rumor has it that Dwayne Pyle was supportive of this contest. I know that Bob Corfidge was, at least 2 of the faculty therefore. And both of them left the faculty a year or 2 later, so I'm not sure if there's any connection, but
Yes, Rich.
Having taken a retrospective walk of the 4th floor on the way here today, I'm pleased to see that the doors do have things taped onto them, continuing this tradition.
All right. On the website, you'll find this full list of the graduate students in the fall of 1968. I see. Yeah.
What happened to Zickerman? He graduated? We didn't need him any longer after we moved to math sciences.
he had a fake preliminary exam. He had all kinds of things.
Okay, this is the office assignment floor map. There was a story about 2 offices. Nobody's quite sure which 2 offices they were, so we've tentatively marked. They're in that area. The problem with cross-wired thermostats, of course, is that one office gets very warm, and he keeps turning it down to get it cooler, which cools down the other office, and so he keeps moving it up to make it warmer, and you aren't really sure, you know, you just think it's not working. You don't realize that there's a negative feedback involved. So that was the the thermostat story. Apparently, huh? Carthage and Young. Okay. Okay. Oh, wrong direction. Apparently, some year when I wasn't there anymore, people were playing Frisbee, and that would not have been so remarkable. I mean, it's a nice straight hallway, except there was apparently an incident about a lost Frisbee. It seems to have ended in Professor Halstead's office.
The Mimeo room.
Oh, it was the other direction?
Yeah, that's where he vanished. See if we can get the Mimeo room.
Oh, I thought the point.
The room was locked. We lost our Frisbee. We had to try to go request it back. And I checked today. There is, in fact, a large enough gap to get back to the I didn't remember it wrong.
Oh, this is just a class thing again because we didn't fully coordinate and so. The next major topic on the agenda was the courses offered, and so this is 2 separate terms of seminars and the seminar topics, and these would be mainly of interest to those of us who were there to see some of our friends' names again. This is the syllabus handed out at the beginning of the term that I took, CS 600, from Mr. Axum. Mr. Axum was working for his PhD at Purdue, and so as a graduate student he was teaching. He had worked at TR, which was not yet TRW, and his boss, who did have a PhD, told him that this particular fellow needed to go back to school and get his PhD because it would open up great doors for him. So even though he was already married and had 2 small children, he enrolled at Purdue. He did eventually get his PhD. I eventually followed him to IBM. What I pointed out with the arrow on this slide is that as part of this course, you would obtain experience in producing a programming language translator. So I saw earlier that a whole bunch of you wrote translators for Dr. Halstead. This was my introduction to writing translators. And it says here, each student will be required to write a compiler as a term project, with the grade being 20 to 30% based on the compiler. So if you weren't prepared for that requirement, you didn't belong in this class. This was very exciting to me. I had already obviously committed myself to computers as distinct from just mathematics, and now I knew that I was interested in compilers and operating systems, and that's where I did my research and development for the rest of my professional career. So I'm very grateful to Dr. Larry Axum for waking up that interest. And I believe this is the end of this part of the presentation. And this is one of those infamous handwritten spirit duplications.
Except it was not actually written by Dr. Halstead. We have the pair of conspirators here today. Do you want to run a little background on how this got set up, Tom? And then we're going to tag team. Okay. We were near the secretary's office, and Dr. Halstead would periodically go and consult in industry, sometimes on short notice. And we were around, and we got word he got a sudden trip he hadn't expected, and he was going to be he was going to be gone the next day. And the class, the compiler class we had taken at the previous term, was not going to be held. The secretary was going to go tell the students to go home, you know. And we had an evil idea. There was this material on syntax classes and source expressions and compiler grammar analysis, and it was a section that was not well covered. In fact, you skipped it.
It was skipped the previous semester.
And we said, you know, how about, right on the spot we talked, how about we put together a fake quiz and hit the students with it? And she demurred a little and said, well, you're not going to keep them more than 10 minutes, okay? You know, good deal. So.
Well, remember, this is material that wasn't covered in the class. So we had to figure out the chapter. We stayed up all night just to figure out how it worked. And, I mean, it looks very peculiar, and it was. This is the most incomprehensible part of the book, which is probably why it wasn't covered by Dr. Halstead. And we stayed up all night and made up a fake pop quiz. The test was administered, but it was open book. So if you figured it out, at the end it said fake quiz.
Let's just advance the slides.
I didn't copy the second one into the slides.
You didn't?
Oh.
Because I didn't know what it was.
The answer to the puzzle, if you applied the algorithm, was fake quiz, turn in and leave. Say nothing, turn in and leave. And so the secretary eventually agreed to go to the class the next morning and announce that Dr. Halstead wasn't present, but he had left a quiz for everyone. And we were close enough not to see, but to hear.
And
So I,
well, Well, we have
Ruth
one
is-
of the inflictees here.
Right. I was a student in that class, and I'm guessing Mary was too. Were you in that class? Well, I remember it, and I understood it. It wasn't that incomprehensible to me. So I was the first one to figure it out, and I started laughing. And I got up and turned in my paper, and then I remembered that I forgot a period at the end of the thing. So as I was leaving, I turned around and went back and said, I need my paper back. And of course, everybody thought I was cheating or did something. I needed it. But it was great fun. They did a wonderful job with it, and it became legend.
Well, and we made it in writing to look like Dr. Halstead's
Halstead's
writing.
right.
Oh, yeah. What's not shown here, there's two other slides. Maybe we'll run across them later or show them at the end in recreation or something. The second page was a complete, complicated list of syntax parse trees with nodes on it and so on. And if you worked your way down those, it was tough. Instead, if you went to the bottom and you found one of these syntax classes there, like the one that says, I think SA is in one of them, it's in LP. It said LP class, 7 was right above it, so you counted over 7, and you found SA, and you wrote that down. Then you got Y, and then you got period, and you could just walk right across the bottom and figure it out very quickly. If you tried to come down from the top, life was not very good for you.
Anybody fail to figure it out?
I think so. I think she dismissed them after 10 minutes.
Tristan didn't finish.
Of course. Anyway, if we find the slides, you can see how it does. The only other observation coming back to this thing is it's an ambiguous grammar. Unless you have a greedy parser, it's an ambiguous grammar.
Okay.
One other thing, just last comment was, after this was all over, and Dr. Halstead came back, and he wasn't really upset or anything, but neither was he interested or intrigued. We pointed out that we had found 4 typographical errors in the book, and his only comment was, I knew about 2 of them. And he never asked about the others.
Thank you for that. That's it.